Welcome to lesson 7 of my refresher course. So today I'm going to talk about inequalities and absolute value. So when you come to the algebra section, it's basically got it's got a few main areas, but you've got like sort of solving quadratic equations and things like this, and you have sort of simultaneous equations and stuff like that. And then you have another section which is it's a bit of a mixed bag, right? So in there, you've got inequalities, you've got these questions about absolute value and stuff like this. So it's sort of like, let's say, kind of scraping the bottom of the barrel for like algebra questions on leaving cert. But what I would say about it is that essentially, if you're kind of comfortable with your algebra, and this is some of the more, not really obscure, but just some of the more like awkward, um, small different topics that come up. If you're comfortable here, it's a good sign, basically. It means that you're sort of like, it means you're kind of gaining kind of fluency, as if you can kind of speak this stuff. So you see an equation, you know what to do, right? So it's a good topic in part for that reason. Okay, so what are we going to do? So we're going to solve some linear inequalities, some quadratic inequalities, some rational inequalities, so inequalities with fractions, and also inequalities with these absolute value signs. And we're also going to like use like graphs a lot, and we're also going to solve things algebraically. We can also sub in numbers sometimes to check, for example, if something works. And we're going to show our solutions on number lines a lot as well, right? Because what's going to happen here is like in previous topics, the question might be, solve for x, and at the end you're going to say like x is equal to something like 5 or something. That might be the answer to the question. Or maybe there's two values of x, x1, x2, and the second one is equal to 7. But here what we're going to have is like x is like greater than 5, and then that'll be our answer. And this is not just like some single number. It's like a whole solution set. So the best thing to do in that case is to draw like a number line, right? So you always put your 0. Well, I usually put my 0 on the number line. And here, the only thing that we have to decide is this is greater than 5. Okay, so it's that side, but it's not greater than or equal to. So we have to put an open circle there. Okay, and then we can just highlight that there a little bit, and then go on like this, just an arrow like that. That's probably a little awkwardly drawn, but you get the point. So we're going to use number lines to show our solutions. And we can also use interval notation. For example, here x is greater than 5. We could say open bracket 5, comma, and then infinity. So this is a way, like if we wanted to, for example, get this piece of the line here, including 0, but not including 5, that would be close bracket 0, comma 5. This is just interval notation, basically. Okay, so some of the symbols that we use, sorry, I wrote this on my computer, so it'll be different. So it would really be like this. That would be the symbol, right? So less than or equal to, greater than or equal to. Then the intervals will either have these round brackets, which basically means that we have like there's A and there's B. So we're talking about between A and B, but not including A and B. Or if we wanted to include A and B, then we would have to like fill those circles, right? So for this one here, we would have to fill those circles, okay? Now, what if we wanted to say like the complement of that set, right? Like, so everything else that isn't A and B, in other words, what if we want to say, so we have what we have here highlighted is this open interval from A to B. So that's that thing. Okay, but what if we want to say everything else besides that set? Okay, so that would be, well, it would be A, because A is not in here because of this open bracket. And then it would be everything back here going back to minus infinity, and then it would be B, and everything in front of B going to forwards infinity. And how would we represent that in interval notation? Well, let's look at this first interval. So essentially, this is very hand wavy. Obviously, we're thinking that it can start from minus infinity. So they're saying I have infinity here just because I couldn't find the infinity symbol. Like this, okay? So this is the way that we get that piece of it, and this is the way that we get this piece. So it's including B, starting at B, and then going up to plus infinity. And then if we want to represent that, we have to take the union of those two sets, okay? Now, if you're doing the exam, you can write this in a number of different ways. You could say, basically my answer is, let's say we're trying to get the green bit, right? We could say, here is like x is less than a, right? Less than or equal to a. Let me write it in green so I don't confuse things. X is less than or equal to a. X is greater than or equal to b. And see what we have here? We have x is less than or equal to a. Well, that's at the same time as like a is greater than or equal to x, isn't it? And then the second one is x is greater than or equal to b. And what we can do is we can combine that and make a sort of you can do this kind of notation with like inequalities. With intervals like this. Like if I'm going to say like x is equal to 2, I can't have a 1 on the other side. Like that doesn't make any sense. But if I have x's between 1 and 2, I can do this. Okay, so that's why I can have these sort of triple statements when we're dealing with like inequalities, right? So we could write the answer like this, or we could write it like with the number line, or we could write it like this, and it's not going to matter unless they tell you specifically. Just do what you prefer to do in the exam. Okay, so what do I have here? So we're just going to think about an example here. Yeah, so we're just going to do it for the example of a line. And do I have one? Let's just do it for the example of a real line. Sorry. So instead of having ax plus b is less than k, let's give it real numbers. So let's say like 2x plus 5 is less than like 7. Okay, so what I want to do is solve this inequality, right? And what I want to end up with is x on its own on one side with something else on the other side. So if it was an equation, that's what I always do with inequalities. Like, so, if I have like 2x plus 5 is equal to 7, then it's like obvious what to do. Like it's just 2x is equal to 7 minus 5. And then it's like 2x is equal to 2, and then x is equal to 1. Well, the rule is when we come to dealing with inequalities, we're going to do everything that we do with equations. And there's just one special case that we have to worry about, which I'll show you in a moment. Okay, so first of all, that means that 2x is less than 7 minus 5. So 2x is less than 2, and that means that x is less than 1. So we just did everything exactly the same. And this is enough for a solution, but if we wanted to represent it graphically, we could draw a number line, and we have 0, and then we have 1, and it's less than 1, right? So I'm going to do it like this, and then let me see if I have some kind of pen or something, and then like this. Oh, good. Need to get some kind of pen. Use this one? No. This one. That looks okay. My God, it's not good. Sorry. See if this one works. Well, you get the idea anyway. Let me try this one. There we go. Perfect. I'll remember that. Okay. Okay, so I'm going to talk about the exception now. What if it was minus 2x plus 5 is less than 7? Like, what if it was minus 2x plus 5 is less than 7? Okay, so we do it in the exact same way. Minus 2x is 7 minus 5, and then minus 2x is less than 2. And then we're going to say, well, like x is something 2 over minus 2, and that's, that's x. Deliberately leaving it out. The one thing that we have to remember when we do this is that we flip the direction of the inequality when we divide or multiply by a minus sign, right? It's easy to see if you just consider the following example: minus x less than 1. Okay, how about I don't multiply both sides by minus sign. I just like bring the x over and bring this one over. So I have minus 1 when this comes over is less than x. So but if minus 1 is less than x, I can flip this around. X is greater than minus 1, okay? So it's the one thing that you have to remember, that if you, and in some cases, like imagine, we'll see this in a few minutes, but imagine if I have like, I don't know, let's say x plus 2 divided by x is less than 2, right? I cannot do the following. I cannot say x plus 2 is less than 2x. The reason why I cannot do that is because I don't know I don't know if x is positive or negative. Because if x was negative, that would have to flip around. So if I'm going to do this thing, I have to know that I'm multiplying across by something positive. So what do? I multiply both sides by x squared. And I'm just left over with an x here. More on that later. But it's just the one thing about inequalities that you really have to remember. Okay. Okay. And the other thing that we could do is we could take, let's just take this example here. So let me just rewrite this equation. So the equation, first of all, we want to think about this with a graphical example. So 2x plus 5 is equal to 7, is it? Oh, yeah. Sorry. Yeah. What am I talking about? Let me talk about this now on the next page as if it was a line. That's what I mean. So let's say y is equal to 2x plus 5. And the question is, tell me where y is greater than 7. Okay. So where is y greater than 7? Now, that would mean if y is greater than 7, then we've got like 2x plus 5 is greater than 7, right? Which is what we had before. So that's like 2x is greater than 7 minus 5. So that's 2x is greater than 2. That's x is greater than 1. Okay, so when x is greater than 1, y is greater than 7. Okay, how can we think about this? Well, let's just now see, we also realize that we have a line. So this is my M, this is my C. Let me draw my axes. Okay, so this is now, so I need to go up to 1, 2, 3, 4, and 5. There we go. And I have a slope of 2. 1, 2, 3, 4, 5. Okay, 6, 7. Now, if I have a slope of 2, if M is equal to 2, then that would mean after taking one step, I go up by 2. I'd get up to that point there, you see? And let's draw that. Okay, so I know I'm concentrating on a simpler example, and the main reason is that, so this is the first point, and this is the second point. Okay, so the question is, where is y? This is y is equal to 7. Okay, so y greater than 7 means specifically up here. Okay, which maps to this here part of the graph, right? Which maps down to this here, x here is equal to 1, which is this piece here. Not including this one here. So you can see this way of looking at it with a graph, that when x is greater than 1, then that means that y is greater than 7. If x was equal to 1, that's when y is equal to 7. So we can solve it algebraically like so, or else we can understand this graphically, which will be important when we go to look at quadratics. This is what this slide is saying. Okay, so then we have the algebraic method, yeah, and that's fine. And we're going to start looking at some quadratic inequalities. And something that might come up for these quadratic inequalities is that we might want to look at this discriminant. So let me just talk about what the discriminant is. Okay, so I'll just talk about it really briefly. I'm not going to prove it again because we did this in like the second lesson, I think. Okay, so x now. So if we can't solve this by doing factors like this, using this method, right? If we can't solve it finding factors, we have to use the quadratic formula. So minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now in here, underneath the square root, we have this thing here, b squared minus 4ac. This is the discriminant. Often it's given this triangle thing. Okay, it's just a symbol because it's just a symbol that we use. Sorry, my microphone disconnected. It's just a symbol that we use because of this thing. Now, if we look at this, there are 3 possibilities, right? Okay, the first possibility is that it's greater than 0. If it's greater than 0, then we can find the square root of it, because the square root of a positive number, like the square root of 4, is just equal to 2 or minus 2, okay? Okay, the next one is that the discriminant is equal to 0. So in this case here, we get two real roots, okay? Here we get like a double root, right? So that's like, you know, just the same root twice. And then here, when what we get is, we get it, if we have the discriminant less than 0, then there are no real roots. This is when we get into complex numbers and stuff. Now, the first case corresponds to, like, imagine an XY axis where we cut across the axis in 2 points. The second case corresponds to a case where we just cut it, the U dips down and just touches the axis in 1 point. And then the third case here, when it's less than 0, see, we can't get the square root of a minus number. It doesn't make any sense. So then this here is a kind of a tool for telling us where we cross the axis, right? But if we end up getting like something that doesn't make sense, then the answer is it doesn't cross the axis. Okay, the question didn't make sense. If you get a stupid answer, you've asked a stupid question. Is the idea of this, right? So we've gotten the square root of a minus number if this b squared minus 4ac is less than 0, and that would mean a u shape that doesn't quite touch the axis. Now, the reason why we care about this is that we're about to start talking about like solving quadratic inequalities. And if we're like, see, we will be able to represent the function either as like f of x algebraically, but we could also think about the curve as well. That's also another representation of the function. It's a graphical representation of the function. And if we were going to say something like, you know, f of x is greater than 0, right, then that would be these bits of it, you see? And that's what we'll have to be finding now in a minute. Now, as I say, like if for here, let's say f of x is less than 0, that never happens. The u never dips underneath the level of the water or something, okay? It doesn't go below the x-axis. Okay, great. So we have an actual question to solve. So let's get to it. Sorry, this needs to be tidied up a bit. Okay, so I have this question here. It's asking, when is x squared minus 5x plus 6 equal to 0? Okay, or greater than or equal to 0, sorry. So we have to solve the quadratic inequality. Now, what I'm going to do when I do these things is, like, let's say step 1, I'm going to make a quadratic equation. So I'm going to get in a quadratic equation. That's going to be my step 1. Okay, so step 2, I'm going to find the roots of that. And then I'm going to, step 3, I'm going to sketch it. And then step 4, I'm going to go back and consider what all this inequality business is kind of doing, okay? So let me just fix this. Okay. So what I'm saying is take the quadratic inequality and then change it to a quadratic equation. X squared minus 5x plus 6 is equal to 0. This is just a step in solving it. We're not forgetting about it. We're just doing the first step in solving it. Okay, brackets, and then two numbers that multiply to be 6 and then add to be minus 5. Well, we have 1 and 6, and 1 and 6 can give us 5, but only if they have different signs, right? But because we have a plus, that means that the two numbers that multiply to give us 6 have to have the same sign. This has to be x minus 2 and x minus 3. Okay, we did this in another one. So it's just a technique. And here we can immediately say, okay, we have this thing multiplied by this thing equal to 0. So either the first thing is equal to 0 or the second thing is equal to 0. So then we have like x is equal to 2 or x is equal to 3. Okay. And these are the roots. So that's step 2, though. These are the roots, and we just found them. Now we go to sketch. And in order to sketch, well, we have to look at this quadratic equation, and we have to look in particular at the coefficient of the x squared. We see it's a +1, so that means it's a U shape, right? So this is a U shape, right? And then it has two roots, and they're both different. So it cuts the axis in like 2 places. And the 2 places where it cuts the axis are 2 and 3. Okay, so now we've done step 3. Okay, we've done step 3. Sorry, I just want to have some colors ready. Okay, so now we've done step 3. The last step is basically to look at the inequality again, okay? And now this is where we have to interpret, okay? So we're saying, when is this thing greater than or equal to 0? Let's call it f of x. F of x is equal to x squared minus 5x plus 6. Okay, we'll call it f of x. And this parabola here is also f of x, right? So f of x can be given to us, you know, as an algebraic thing, in which we can do algebra with it, or it can be given to us as a graph, in which case we can just look at it and maybe, you know, be able to recognize something from it. Okay, so this question, when is f of x greater than or equal to 0, is much clearer when we look at the parabola. So we just look here. You see, it's greater than 0. Bad color. I'm just going to. It's greater than 0 here and here. Greater than or equal to 0. Okay. So now, so these are the stems of the. Now we have to think. Okay, take all of these yellow lines and just drop them vertically down. And also it's okay for it to be equal to 0, so we can have these points. So what we're going to do is when we just sort of let that, like, I don't know, like a wet cloth or something just fall down and hit the ground, it's just going to be like these will be the values of x. I chose a bad color. Let me just do it again. So let's say these are the this is the part of f of x that's greater than 0, and then what values of x give us that? Well, it's just starting here and then going in this direction backwards, and then this direction forwards. Okay, so now we've looked at the inequality and we've used the sketch to be able to get that, and now we're kind of done, right? Because we have represented it on a number line. Like, this is kind of enough, but maybe we want to say it like a little bit more, just like, I don't want to say like this is a fine solution. I don't want to say that it's not. If you give this an exam, I think that you get the marks, but it could be that you're asked to give it in a different way. So let's just give it in a different way just to make sure that we're prepared to potentially do that, right? Okay, so we want to be able to, this green part of the x-axis, what is that? Well, it's x is less than 2, but it's also, sorry, less than or equal to 2 because we have them filled in. And it's also x is greater than or equal to 3, okay? That's also enough, but you know what? Maybe we just want to do this, okay? And you know what? Maybe we just want to do this sort of stuff, okay? So if you were sort of like, just to comment just on what I did just right there that moment, I said this was probably enough, and then I ended up filling up half the page with some more maths. And if you were naive, like looking at this, you might think that this is, if you didn't know what these symbols mean, you might think that this was a very sort of complicated extra part, but it wasn't. It was just sort of basically sorting out our answer and just sort of dotting all the I's and crossing all the T's kind of thing. Okay, so let's have a look at an exam question. And then as soon as we look at the exam question, we can move on to the examples of rational inequalities. And then we can move on to the example of the absolute value. Okay. So I want to take a nice and easy, I don't want to overload you with information. The point is really to kind of get you back into the swing of things. Okay, so what's our steps? So when we solve this is a Leaving Cert exam. I don't know what year, like last year or the year before, something like that. Okay, so what's our first step? So we want to solve the equation. Oh yeah, so we want to write the equation. So we want to get the equation from the inequality. The second one we want to solve, basically get the roots. The third step is we want to sketch it. And then the fourth step is we want to now look at the sketch and then consider all this stuff with the inequalities, and then we can move to the solution. And what I'm going to do, just because I'm going to need it, what I'm going to do is I'm going to just write down explicitly the function just for a second. It's not necessary to do this, but okay, so we're saying like, when is this thing greater than 0? But the other thing is like, when is the function greater than 0? That's what they're saying. Okay, so let's take the equation. So we just take the exact same thing again, and we set it equal to 0. Okay, and now like maybe I need to use the quadratic formula here. Maybe not. Let's give it a go. I'd always give this a shot first because it's so much faster. So two numbers that multiply to give me 2x squared it can only be 2x and x, okay? It obviously could be like, whatever, 1.5 and something, but that's when you need the quadratic formula, okay? So, and then we have two numbers that multiply to give us minus 15. Well, those two numbers have to have a different sign because of the minus, okay? And like, so we could have 1 and 15, or we could have 3 and 5, but minus and minus, right? And the point here is we need to end up with a +1. And you know what? If I put a 3 here and I put a 5 here, then I'll have a 6. And then I'll have a 5. And I can get a 1 from a 6 and a 5. And you know what? This would have to be the plus, wouldn't it? Because then I will have a +6 and then a -5 here, like that. Okay, so 2x times 3 is 6x minus 5x. Okay, so now I can write down either 2x minus 5 is equal to 0 or x plus 3 is equal to 0. And that first one gives me that 2x is equal to 5, and the second one gives me that x is equal to -3. And then this one here actually gives me that x is equal to 5/2. Okay, so now what I'm going to do, so I've done step 1, I changed it into an equation. Step 2, I solved that and found the roots, this one here and this one here. And then the next step is I'm going to draw a sketch of this now, okay? So what numbers do I have? So I'll draw the xy axis. Okay, I notice looking at the coefficient in front of the x squared, that's a 2, so it's a plus, so this is a U shape, okay? So it's a U-shaped graph. And I have like a -3 and a 5/2, which is like something like this. And so I have a U shape. Let's see if I can draw it. Something like that, right? This is my U shape. And okay, so I'm finished with step 1, 2, and 3. And now I want to go back to the inequality, and I want to realize, okay, first of all, this is f of x. This is also f of x. So where's f of x greater than or equal to 0? Well, this stem is where it's greater than 0. Think about, like, don't be afraid to think about silly examples. Like I think about like bending one of these rulers, these bendy rulers, and just like dipping it in water. And it's just like, which is the bit that's dry, And the important thing about if you do things like that, or even using different colors or connect, what you're doing is you're sort of connecting to your intuition and other faculties. Like this doesn't have to be all abstract. If you're able to kind of think about it in a kind of a normal way, it can mean much, much less brain work, but that's a personal thing. Okay, so these are the two stems where the graph is greater than or equal to 0. What do they correspond to? Well, they correspond to this piece here and this piece here, okay? Now that first piece, let's write it down, x is less than -3, and that second piece, less than or equal to. I lost a mark for no good reason there. That would be a star. That would be, that would be -1, basically. X greater than or 5/2. And then, okay, so we have x is less than or equal to -3, and then x is greater than or equal to 5/2. Then we can flip this one around, -3 less than or equal to x, and then x is so less than or equal to 5/2. So that's also correct. This is correct. That's correct as well. And so I'd find the set of all values. You could also write -infinity up to 3, close a square bracket, union, open a square bracket, 5/2 up to infinity, using the interval notation. Everything's good, whatever you prefer. So we'll look quickly at so here they have it, exactly the same thing. And then this graph here, and then you can see x, where, see this stuff here, x, and then this line here. And yesterday I said that means divides, when I was talking about particular example from induction, but when it's in these curly brackets, it means all x where x is less than -3. And all x where, so there's a few different ways that you can write that, but you need to make the point, okay? This makes the point. This here makes the point, okay? So like that should be enough, okay? And they have another method. Yeah, so then they ended up saying like x was greater than or equal to -3, and x is greater than 5/2. X is less than -3, and x is, oh yeah, so I think they had, what did they do here? Oh yeah, so what you could do is you could sort of, basically you could take, it doesn't really matter. I don't really want to get into this too much, but basically you can take like this here and this one here. So you can take like the greater than condition for both of them and find out which one is stronger, and then take the less than condition and find out which one is stronger. So you get this one and this one. Doesn't matter. There's a few different ways to write the answer. Okay, so the next one that we come on to is sorry. The next one that we come on to now is basically rational inequalities, right? So rational means ratio, means fraction. So it's an inequality with a fraction. And let me just think for a moment. I want to think if there is a better way to answer this question. No, I think there's just one way. I was thinking was there a second method, but I think it's not necessary. Okay, so let's have a look and imagine for a moment that this was an equation. So we could write this down as an equation is equal to 1. And then we'd have to have a little condition afterwards. We would have to say, by the way, x is not equal to 1. Sorry, we'd have to say x is not equal to -1. Why? Because -1 and +1 would give a 0 below the line, and then we'd be dividing by 0. Okay, now if we had that, we would just multiply across. 2x minus 3 is equal to 1 times like x plus 1. And this is like 2x minus 3 is equal to x plus 1, and so on. And you would solve it then. Now, we cannot do that here. And the reason why we cannot do it here is we do not know what sign x plus 1 has, because x is basically all the numbers on the number line, right? So all the numbers on the number line, you got 0, and then this goes back to -infinity. This goes up to +infinity at 0, sorry, and this is the number line for x. So half the numbers are negative and half of them are positive, and we just need for them to be less than 1, less than -1 in order for us to have negative numbers, okay? So what should we do? Okay, so what we need to do is we need to multiply both sides across by something that we know is positive. So let's take the left-hand side, 2x minus 3 over x plus 1 greater than 1. And we're going to multiply by something that does two things. We know something that we know is positive and something that cancels off my denominator, so I don't have this on the other side. And what is that? It's the denominator squared. Okay, it's a little trick. Now, the nice thing about this, like what I really like about this example, is that this is the only part that you really need to think about, right? Like when you're doing this problem, it comes up and you're like, oh yeah, what was that thing that I had then? And it was like, oh yeah, I had to multiply both sides by x plus 1 to be squared. The rest of this now is just, it's just canceling and multiplying out. Like, hopefully we're good enough at that, we get confident enough with it that, we actually don't have to, we can just do it kind of without thinking. We just do it kind of carefully. It's a little bit like walking, right? Like, so this is like someone gave you the directions. They said, oh yeah, just go down the road, take a left. Now you know where to go. And now it's just step by step by step to the answer, okay? So first things first is we cancel off 1 power here with the bottom here. And let's then multiply out. So we have then x times 2x is 2x squared. X times 3 is minus 3x. 1 times x is plus 2x. And then 1 times minus 3 is like minus 3. Okay, and then the other side, well, the 1 doesn't make a difference. So we just have to multiply out. Let's go over here and just do it quickly. So we have to multiply out x plus 1 all squared. So we have x squared. We've got a 1x from here. We have a 1x that's plus 2x, and then plus a 1 is 1. This is greater than x squared plus 2x plus 1. And now we're going to bring everything over to the left-hand side. And let's have a look at what we end up with. So x squared comes over, and then we end up getting 2x squared minus x squared is just x squared. Then minus 3x. Oh, that minus 3x plus 2x ends up being a minus x. So minus x plus, sorry, minus x minus 2x is minus 3x. And then minus 3, and then minus 1 comes over, then greater than 0. So what have we got then? What we have is something kind of interesting. This here is just a quadratic inequality, which is what we were just doing. right? So what we're going to do is use exactly the same method. So what this means is that this question here is just like a way of asking the previous question, just in with a little twist on it, basically. And so, like, they can't ask you quadratic inequalities all the time. They have to kind of like give a little twist so that when you're doing the exam, you something like this, which is actually a quadratic inequality in hiding. There is one little thing that we're going to have to sort of maybe factor in a minute, and that's that. Okay, but we'll have a look. So let's just start this off on a new page and just pretend like this is the question that we've been given. So x squared minus 3x minus 4 was greater than 0. Okay, so what do? Step 1, we get the equation. Step 2, we get the roots. We sketch. Step 3, we sketch. And step 4, we look at the inequality. Okay, brilliant. So let's take the equation. X squared minus 3x minus 4 is equal to 0. Now let's get the factors. So two numbers that multiply here is x and x. Two numbers that multiply to give me minus 4 would be either 2 and 2 or 1 and 4. And one of them has to be minus and one of them has to be plus, right? And which of those, so it's either 2 by 2 or 1 by 4, and one of them is plus and one of them is minus. Which of those can give us a minus 3? And that's this one. Because we can get 3 by subtracting. And then we'll have a 4 and a 1, and then we want this to be, they'll have different signs, and then we want to have a minus after we add them, so we make that one minus and this one plus. So we have x is equal to minus 1. Well, I just write it the longer way. X plus 1 is equal to 0, or x minus 4 is equal to 0, and then that's x is equal to minus 1, or x is equal to 4. Okay, brilliant. Now we sketch. So it's a plus here in front of the x squared, so it's a U shape. So we'll draw the U shape here, and then what is it, like minus 1 and 4? So I'm going to go like so here is minus 1, and here is 4. Okay. And now I want to look at the inequality, and look what I have. It's greater than 0. So the piece of it that I want out of this is this piece, and this piece here, and this piece here. What x values does that correspond to? Well, it would have to be like not that one, because we're strictly greater than 0. So we're not the place where it's equal to 0, and backwards. So in other words, x is less than minus 1. And then here, x is greater than. So if you remember what I was saying before, I was sort of saying like a function can be represented algebraically, or it could be represented as a graph. And, you know, basically the algebra gives us exactness, but maybe no intuition. And the graph gives us like intuition without exactness, right? So we knew that this was minus 4, 1. We knew this is 4. So then we can look at the graph and kind of get that from it. And like, you know, maybe that feels like not maths in a sense, but, you know, I like to think of maths as a way to basically take, you know, the kind of abilities that you have and just to make it like really formal logic stuff, like make everything kind of like if you're gonna like write a sentence in, you know, it's not like there's no maybes, or it's a way of writing that everything is kind of exact and stuff like that. But still, you're still kind of thinking in like the way that you know you want to make it as natural as possible or something like that. So that means if you have a picture and you can interpret something from that, that's a perfectly valid thing. We wouldn't be able to sort of draw the picture and then guess what the minus 1 and 4. Like we have to get that bit from the algebra, but then like from the sketch bit, we can really intuit the answer. Okay, so this gives us, well, minus, what do we have? So we have x is less than minus 1, and x is greater than 4, and then that means that minus 1 is less than x, and then x is greater than 4. So then, no, what am I saying? Sorry, that gives us that minus 1 is greater than x, and then x is greater than 4. So that's minus 1 greater than x, x greater than 4. That's the answer. Now, I did allude to something. I want to come back to it. What about this x is not equal to -1? And let me just like quickly, briefly mention this. So let's just draw the graph again. Sorry. And there's -1. And there is 4. And then we can draw the graph like this. Okay, so this function, if we call it f of x, is equal to 2x minus 3 over x plus 1, is exactly the same as this function, which is x squared minus 3x minus 4, after we do our sort of algebra. Or the question of where this is greater than 1 is exactly the same as where this one here is greater than 0. So what I'm trying to say is, like, I think this may not be exactly the case, but what I'm trying to say is that this thing is another way of writing that thing there. But this thing here, because we're dividing by x plus 1, it means that x is not able to be equal to -1, right? And that means that when we go in here into the graph of this rational algebraic thing is exactly the same as the quadratic, except it has a hole in it. It has one place, so it's basically like something like this with a tiny hole in it. So it's exactly the same as the quadratic, except it just has one place where it's not working. Okay, and that's so what that means is like we can use all of the normal stuff that we use for quadratics as long as we avoid this particular trapdoor where where it doesn't work, right? So that's kind of like, how do you say it? It's like, here's a rule that will give us everything we want, but here's this one exception to it, which is great. We can use these rules. We just have to list the times when we can't. Okay. Okay, so we do this one, and then we get on to the modulus stuff. Okay, so I just take this. I'll do this as quickly as I can because I think we want to 3x plus 1 over x minus 1 is less than or equal to 6. And what I'm going to do is multiply both sides by x minus 1 all to be squared. Okay, 1 power here cancels with that there, and I just have, okay, 3x times 3x is 3x squared. X times 1 is plus x, minus 3 times this is minus 3x, and then minus 1 times 1 is minus 1. And that is less than or equal to 6 times, and in brackets, well, let's do it over here. X minus 1 times x minus 1. So x by x is x squared. Minus 1, x by minus 1 is minus 1. Minus 1 by x, so that's minus 2x, and then plus 1. So x squared minus 2x plus 1. So this is like 3x squared minus 2x minus 1 less than or equal to 6x squared minus 12x plus 6. This is a little bit longer, but we should expect that, right? The previous one was like a kind of a book type question. Okay, I'm going to bring over everything to the left-hand side. So let me just look at the 2x squared parts. When I bring over the 3x squared, it'll be 3x squared minus 6x squared. So it'll be minus 3x squared. Now I'll bring over the x's. So it'll be minus 2x minus 12x. So that would be, plus 10x. And then I have the minus 1 minus 1 and the plus 6. So it's going to be minus 1. What's going to be? So minus 1 minus 6 will be minus 7 is less than or equal to 0. I don't like this minus sign out front. Generally, I just, you're always trying to get the thing that you're going to launch off from as like neat as possible. So what I'll do is I'll say that that's going to be multiply both sides by minus 1. So 3x squared minus 10x, then plus 7 and a 0. But we multiply both sides by minus 1. So this is now greater than or equal to. Okay, so this statement here with the rational inequality is the same as this statement here with the equation. So what do? First of all, get the equation 3x squared minus 10x plus 7 is equal to 0. Then I break it, brackets, 3x and x is the only option. 7 and 1 is the only option. And how can I get to 10? Well, if I put the 7 here and the 1 here, you see, and I make them both minus. So then 3 by that would be minus 3, x by this would be minus 7. So minus 3 and minus 7 would be minus 10. So this now is either 3x minus 7 is equal to 0, in which case 3x is equal to 7, in which case x is equal to 7 over 3. And then the second case is x minus 1 is equal to 0, which means that x is equal to 1. So this is one root and this is the other root. And now I go ahead and I plot, there's 1, there's 7 over 3, and then I look at this one. Where is that greater than or equal to 0? It's greater than or equal to 0 in these places, which corresponds to x less than 1 or x greater than 7 over 3, that piece, okay? And that's our answer, and we can write that a bit more neatly if we want to. So there we go, multiply both sides by. Now let's have a look quickly at, okay. So as soon as we're mentioning that, so even just write it down and nothing else down, it's already 3 marks out of 10, right? Now, obviously you want to get 3 marks out of 10, but you should never get 0. You understand? Like you should definitely know what, and all we need for that is this first thing that I said to you, which was like, we have this problem with inequalities that we don't know if x minus 1 is positive or negative. So we don't know if we should be flipping the inequality or not. Okay, so as long as you're like, how do I rectify that? What's my objective? My objective is to get rid of this denominator. And if I multiply both sides by x minus 1 squared, that will do that. And it'll also not have the problem I end up getting is something longer that I have to solve, right? Longer than it would be if it was an equation. Okay, so then it says, so now the other thing says if we've multiplied this, I think if we've, multiplied across. Yeah, so I think if we have, what's it mean, 2 correct linear inequalities? So I think it means like if we get to the next line, basically, and then the high partial credit is getting to this part here. Okay, so absolute value. So we have 10 minutes to talk about absolute value. So let's get into it. So let's say this here is, let's say you live on the y axis, okay? And there's a point which happens to be the shop, and here's a point that happens to be the school, right? You might say, you know what, the distance, so let's say maybe the distance from your house to the shop is like in this direction, and the distance here is this one here. It might turn out that they're equal to each other. But if we look at an xy axis, this might be minus 2 kilometers, this might be plus 2 kilometers. Right. So what we'd like is a way to just say, well, it's just 2 kilometers. I'm not talking about, and how do we do that? Well, we just put an absolute value around the minus 2, and that will always return the plus value. Okay. So you can always think about it as basically the distance from 0. Now, if we wanted to have the distance from A, just from point A, well, then we just draw a number line. And now this time we have the point A, and then we have, like, let's say the point X. Like, we don't know which X could be here, X could be anywhere because it's a variable. So if we want to say now the distance that they are away is just x minus a in the absolute value. And the reason why we put the absolute value on is because it could happen that the x is on this side, right? In which case it would return like a negative, okay? And if we go to graph one of these things, you see what this does is basically it just makes any of the negative stuff positive. So we go ahead and graph our function. And then, like, let's say y, so it's got a slope of 1 and it's got an intercept at minus a or whatever, but it's got this point here, just the way it's written. So it's got an intercept here. So it goes like this. I got that incidentally by just quickly in my head going y equals 0 and x is equal to 0 and getting 2 points out. So I draw that like this, okay? Now what I'm drawing here, see if I can do it. What I'm drawing here is y is equal to x minus a, right? But the problem, if I was to consider y is equal to x minus a in an absolute value, is this piece here. See, that's negative stuff. Y here is negative, but it's not allowed to be negative, so we have to reflect it up, and we get these v's, okay? We get v's, all right? And if we had it with an absolute, imagine we had y was equal to the ax squared plus bx plus c in an absolute value. If we had that, right? Go ahead and I draw there's my nice parabola. However, see, this piece here is all underneath the x-axis all negative, we can't have it. So it has to be, it does this thing. So it makes like these types of shapes, right? And when you don't do it on leave insert, but these things here, these jagged points, these V-shaped things, these they create little problems, you know, because they suddenly turn, they're not smooth, it's a point, and these cause little problems. If you do whatever, any kind of science or engineering course, they'll talk more about it. Okay. And now we want to say, well, you know, what would it mean for x minus a to be less than b? Basically, what we're saying is like, you know, what are the values of x? So like if I have the point, like if I have the, if this is a, I could say like, you know, where are the values of x so that like basically I'm less than a distance of b from, so this is b. So basically what I'm doing is I'm creating a kind of a, you know, a catchment area basically, right? Okay, so now let's go and take an example of how to solve one of these things. Now, there's two ways to solve this, and the first way that I show you will be very much like what we did before, okay? Because what we realize is if 2x minus 3, if this was less than 0, like if this was greater than 0, then this wouldn't do anything, right? But if this is less than 0, then it makes it positive, right? So would there be a way for me to just like to kind of make sure that I have something that's positive, that then I could because if I knew, like if I like the absolute value of 5 is just 5, you can just, as soon as you have a positive thing, you can just like drop the absolute value. And the way to do it is to do the following, is just to square both sides, right? Less than or equal to like 49, right? Because you see that these things only, all they're doing is taking negative numbers and turning them to positive numbers. But if the left hand side is already positive, then we can just drop them, okay? And now what we can do is say 4x squared, like minus like 2, like it's going to be 2 times 2 times 3, which will be minus 12x plus 9 less than 49. And then it's going to be 4x squared minus 12x and then minus 40 less than 0. I'm going to divide across by 4 because I can see it and it's not negative, so it's no problem. So minus 3x and then minus 10 less than or equal to 0, and then two brackets less than or equal to 0. Then we have x, and then two numbers that multiply to give us 10, and then that add to give us minus 3, and that's a 2 and a 5. And we want one to be negative and one to be positive for this here. So that's, this one is negative and this one is positive, okay? And then we add them. So x is equal to minus 2, or x is equal to 5. Okay, so I flipped, sorry, into into that method. Then I go ahead and I draw minus 2 and 5, and then I go ahead and draw this U-shaped here, this U-shaped. And then the bit where it's less than 0 is like this bit here, from here to here, less than or equal to 0. So this piece here. And then the x values that it corresponds to is in here. And how do we write that? Well, we say that x has to be greater than or equal to minus 2, or x has to be less than or equal to 5. And we can write that as like minus 2 less than or equal to x less than or equal to 5. Okay. Now, what's the other way of doing it? So the second way of doing it is just to look at the following situation. So basically here, with this 2x minus 3 less than or equal to 7, well, I actually can break this into two scenarios. Okay, so the first scenario and the second scenario. Now, the first scenario is where 2x minus 3 is greater than 0. What does that mean? That means that whatever here is underneath, inside of the modulus, is already 0, in which case we can say that, you know, 2x minus 3 is less than or equal to 7. We could just simply drop the absolute value sign, because what does the absolute value do? It just takes a positive number, it takes a number, it makes it positive. But if things are already positive, you just leave it. It has a neutral effect on it, right? And then we have these two conditions, and we can solve these two conditions, and we can find which of these two conditions is more powerful. And then the second thing that we have is we have the situation where 2x minus 3 is less than 0. So the situation where this is negative. Okay, so that would mean that minus 2x minus 3 is less than or equal to 7. So what that means, see, this thing here is negative, right? So what does the absolute value do? It makes it positive. And how do we make a negative thing positive? We multiply it by minus 1. And now we get another 2, 3. We get another 2. We have to solve 4 of these linear inequalities. So let's just solve the first one. Number 1. 2x is greater than 3. X is greater than 3 over 2. The next one. 2x is less than or equal to 4. X is less than or equal to 2. That's the second one. The third one, we have to finish now in a moment. 2x minus 3 is less than 0. 2x is less than 3 over 2. And x is less than 3 over 2. And then the last one, minus 2x minus 3 is less than or equal to 7. That means multiply both sides by the minus 1. This is number 4 now. 2x minus 3 is greater than minus 7. That means that 2x is greater than or equal to minus 7 minus 3 is minus 4. And that means that x is greater than or equal to minus 2. So we have 4 conditions. We have the first one, x is greater than 3 over 2. X is less than 2. X is less than 3 over 2. And x is greater than or equal to minus 2. Okay. Okay, almost there. So now we look. I think I've made a mistake. Somewhere. Oh, sorry, this should be 10. This should be 10, minus 10. Something's going wrong. What is it? 2x was greater than. Oh, this was 10. This was 10. Sorry, 2x is greater. So x is greater than or equal to 5. Okay, and then this one here, 2x minus 3, and minus 7. So x is greater than or equal to minus 2. Okay, perfect. Now, what we're going to do is take the two greater than conditions. This is a greater than condition, and this is a greater than condition. And we're going to see which one is stronger. And basically, this one is bigger. So we actually want to take the stronger one will be the one that grabs more of the number line, which is this one. This is the one that grabs more of the number line. And which one grabs? So x is less than 3 over 2, but then x is also less than 5. So this one is the. So see, we get the same answer. All right. Now I leave it up to you to decide which of these two methods is the easier one. And then I have an exam question. I have to go because the next class is starting. So I hope that was helpful, and I'll see you back at the same time tomorrow. Thanks.